again. And now it's time for longest palindromic string, substring actually, from Leetcode. And this is a Python exercise. Settle back and enjoy. All right, looking at the instructions. Given, let me clear my throat. Given a string S, return the longest palindromic substring in S. A palindrome is a string that is the same backwards and forwards. And a palindromic substring would be a substring within a string that is the same backwards and forwards. So we're going to be given a string. We've got to find the longest portion of the string that is a palindrome. Could be the entire string, maybe a substring. Who knows until we get in there and figure it out. Looking at example 1, we have babad. Maybe that's how you say it. But the longest palindromic substring is BAB. Of course, BAB is the same backwards and forwards. And also ABA is a valid answer. So we got to go in and kind of parse and figure out a substring that is the same backwards and forwards. Example 2, CBBD, the longest is BB, there in the middle. No other portion of the string is palindrome. So yeah, the instructions here are short and sweet, but the idea is pretty obvious. Given a string, find the longest portion that is the same backwards and forwards. So digging in here with the code, it's slightly larger. Because I'm going to need to find the longest substring that is palindromic, I am going to maintain a record of which length is the longest so far and which actual string is the longest. So I'm going to create two variables to hold each of those things. One variable for the longest length, one variable for the actual longest string. So one for the longest, and I'll start that at a 1, and this will be the longest string. And I'm going to make the longest string currently just the first character of S. So longest length 1, longest string right now is just the first character of S. I start longest length at 1 because you're not going to have a 0 length palindromic substring, and realistically, a single character is a palindrome. So it's a given that any single character is a palindrome. We're going to find one either longer than that, or each single character would be a palindrome. So I guess long story short, at a minimum, your longest palindrome is going to be 1 character. So go ahead and set it to 1 for the length and the first character of the string. So here's my strategy with this, and I'll draw it out. Let's say we have a string AB. Let's say the string is, even though this is, of course, there's no palindromic portions of this string, but I'm going to use this string to illustrate the strategy. So I start with this. I'm going to use a nested looping situation where I'm going to, in my outer loop, I'm going to loop through the characters of my string, and on the inner loop, I'm going to then, really what I'm doing is I'm using each character as a starting point to create substrings in my inner loop. So here's what I mean. For each character, I'm going to loop through, and in the inner loop, I'm going to start at the next character, so let's say on my first iteration, my I loop is going to start with A. I'm going to then loop through B, C, D, E, F in my J loop, where I'm going to make a progressively larger substring with my substrings will be, on this first turn, they will be A, B, A, B, C, and then A, B, C, D, and then it'll be, you know, A, B, C, D, E. Because really on each iteration of the J loop, the substring gets larger and larger and larger until it's A, B, C, D, E, F. And then I'm checking each one of these to see if they're a palindrome in the process. And then on my second turn of I, what'll happen is A will be out of there, and I'll start with B. And so it'll be, starting with B, it'll be B, C for the first turn, and then it'll be B, C, D, and then it'll be B, C, D, E. So you can look at this one as like my I equals 1 will be these substrings, and my I equals 2 will be this set of substrings. You see the I equals 1 is going to start with A, the I equals 2 will start with B, and so on. And you know, then when I is 3, it's going to be starting with C and going for the rest. This tactic is going to allow me to get to all of the substrings, and then I'll be able to, for each substring, check if they're palindromes or not. All right, on to the code. So going in here, I'm going to start my loop. Length of S, yeah. And I'm going to go actually the length of S minus 1 because my the shortest palindrome or the shortest substring that I'm going to check for really is going to be a substring of 2, because we've already established that the shortest palindrome really is going to be 1, a length of 1. So there's going to be no situation where I'm at the end of my string and I'm going to check to see if the last character by itself is a palindrome. So I'm going the length minus 1 to see if I'm at the end or near the end, it would be the second to last and the last. See if those two are palindrome substring. So there's no reason to go all the way to the end because I'm not going to check for a single character. So yeah, do this. And then on my J loop, oops, in range. My J loop, I'm going to start with I plus 1 and then go the length of S. The J loop goes all the way to the end because if I'm at the end with I or near the end, if I is on the length minus 2, J will be on the length minus 1. Those will be the last two characters, and I'll check for those two those two together being a palindromic substring. So J will go all the way to the end. I will go one before the end. And I'm starting J at I plus 1 because all of the substrings I'm going to check for, I will be the beginning. I is going to be the beginning of each substring that I'm going to check for. So the next set of characters after I will of course start with I plus 1. So that's why my J loop is starting with I plus 1. And I'm going to create my substring. here. I'm going to put it in a variable because it'll be easier to check as it's in a variable. I'm going to create a substring through slicing, or I'm going to take a slice of s going from I, which like I said is going to be the beginning of my substring, I to j plus 1. I'm using j plus 1 because I want to include the character at j in my substring. So I got to go j plus 1 because the end of a slice is not inclusive in Python. So I got that. And there's my substring. So now I can check the substring to see if it is a palindrome. I do that with an if statement. And here's some handy dandy syntax to reverse a string using slice notation. So I'm going to say if the reverse of the string equals the string, or really the substring. So if the reverse of the substring equals the substring, then it is a palindrome. And I'm not only going to check for it being a palindrome, I also want to check for it being longer than the longest established one so far. Because the reason here is we're trying to find the longest palindromic substring. Well, if it's not longer than what we have already, it doesn't matter. So I'm going to check for it being a palindrome and the length of it being greater than my established longest length. If it is, then we are good, and this will be the longest. So I will assign longest len to this one, to this substring. And actually it'll be the length of the substring, because this is the integer length. And longest string will be this. And once these loops are over, I'm going to have my longest palindromic substring. So what is left is to return. Return longest str, because the task here is to return the longest string, not the integer longest length. All right, I'm ready to check this one out. Run it. Accepted, passes the test cases. That's good. And now, drum roll please, I will submit to the real test cases. It is accepted. Very good. Not the most efficient situation, but it works. And this ain't the most efficient code, but it is perhaps a little easier to break down and easier to explain. So this is what I went with. So this is the solution. This is a solution, actually, to the longest palindromic substring from Leetcode. And that's it for me. Enjoy your day, and I am out.